Guys, very good evening to all of you. Once again, welcome to BYJU'S Exam Prep. I'm going to take you through the modern math section of IIFT. In fact, I'm going to talk about how important this particular topic is for the quant section of your IIFT. And of course, as usual in all our last labs, I'm going to take you through the theory part, the most important parts of the theory, and few questions for solving so that you get the grasp of these concepts. Right? So let's go ahead and take a look at this topic called modern math. But before we get ahead and take a look at the concepts and things which are involved, let's first understand what are the topics that fall under this modern math. The modern math concepts or the topics that fall under this area, first is set theory plus Venn diagrams. Okay, I'm sure you all know this. The second topic that comes under this is permutation and combination, and the third topic is probability. Now, these three constitute this area of modern math, and as far as IIFT is concerned, these topics have a decent weightage in the quant section of the exam. Right, so let's go and take a look at the weightage, how many questions are expected, what has happened in the last few years. Okay. So, as I said, this comes into quantitative area, modern maths, weightage is almost 10 to 15% of your mathematics paper, that is the quant section. Okay, if you look at the year-wise breakup, what happened in the last 3 to 4 years? So, this is what happened. Set theory, permutation, combination, probability, already mentioned. But yeah, this is what happened in the last 4 years. Last year, the total number of questions were 110. Quant was 25 questions and 4 questions were from this topic. So 4 questions it's about 16%, right? 16% of your quant section is from this. The year before it had 3 questions and the year before that 2 questions. So you can see slowly the number of questions coming from this area have been increasing over the last 3 years. Now, you can say that it's a trend, but I don't think it will go more than 3 to 4 questions. Please don't expect this year to be 5 or 6. I'll be surprised if there are 5 or 6, but yeah, you can expect somewhere in this range because I believe that modern math is something which normally an MBA entrance exam can ask, but not too much of it. Because it is not arithmetic, usually they focus a lot on arithmetic because all the management entrance exams focus on asking basic math. So one of the basic math areas is arithmetic, so they will focus a lot on that. And this is one area which can be asked, but not at a high rate as 30-40%. So don't expect more than 4-5 questions. 5 is still fine, I can live with it, but not more than 5 out of 25 questions. So that's something that you have to keep in mind. I've got a couple of comments coming my way. Let me see what will be the level of difficulty in this session. Mandeep, I have 1 or 2 easy questions slowly going up to higher level questions. So you will get all types of questions as a part of the level of difficulty. Okay. Mandeep, geometry is not modern math. Modern math, as I explained, are the 3 topics that I just mentioned. Right. So, in fact, Mayank is saying, okay, I think Mayank said something to which modern math like P and C. Yes. Probability is important, Kavya. Yes, the questions have come. So probability is important for 2 exams, both IIFT as well as IIFT. SNAP also asks probability and even XAT asks probability. In fact, CAT is the only exam which does not get into probability at all. NMAT asks probability, SNAP asks probability, IIFT asks probability, and XAT also asks probability. CAT usually refrains from asking too many probability based questions. Okay. Where is it mentioned geometry? Where is geometry in this? Never mind. So yeah, let's go on. Geometry is written in your slide. Where? I don't think there was geometry. This is not geometry. My bad. Okay, this is not geometry. This is P and C. Thanks for that. Okay. Logarithms belong to algebra, Mandeep. Okay. So let's start by understanding some of the basic concepts and the important areas within the concept. Okay. The first concept we're going to talk about is set theory. Now, set theory is basically understanding of Venn diagrams, right? Simple Venn diagrams involving 2 parameters, 3 parameters, rare cases 4 parameters also. Right? So 2 parameters, this is how the Venn diagram is. You will have one circle here, you will have the second circle here, and the areas are quite easy for you to understand, but let me highlight them. The first circle will be called as N of A. N of A basically represents the set A, right? So the first circle represents the set A. N of A represents the number of items in this set A. Number of items in this set A. Similarly, the second circle represents set B. And N of B represents the number of items in set B. Okay? Then you have the intersection part, which is common to both. This is called as the intersection part or the common to both sets. It is represented as N of A intersection B. And of course you have N of A union B. What is union? Union is everything within the part of both the circles. So this middle part and this, all these three. So this part, the middle part and this together will be called as union. So union does not, the only thing about union is it should be part of either this circle, that circle could be part of both also, but it should be within the circular frame. Then it is called as A union B. Then you have an idea of this bar. What does this bar mean? If I write B dash, what is the meaning of B dash? B dash basically means things which are not in B. Things which are not in B. So basically what this means, A intersection B dash, basically it means I am looking at only A. Only A, because you can see this part of the circle, that I am shading here, talks, or what does it represent? It represents only the portion of the circle which is not there as a part of B. So this is not there. This entire thing is not there. So you are not talking about it. You are only talking about the part which is representing only A, nothing else in it. Okay. Similarly, this part talks about the part which is there only in B. So this B bar is basically called as complement. Okay. It's called as complement. Basically, complement means everything except B. That is the meaning. Okay. Anyway, so the funda here, guys, is don't get too technical about it. Understand the figure. If you understand the figure, the job is done. So if you understand the figure, what is A union B? So let us call this as X, Y and Z. So you have A union B is X plus Y plus Z. Do you agree? Now what is A? Your A is X plus Y. Correct? And what is B? B is Y plus Z. If you add these two, what do you get? You get A plus B is equal to X plus 2Y plus Z. Now you have 2Y. I want to get A union B using only A plus B. So what should I do? I got an extra Y. I want to subtract that extra Y. So what I'll do is I will write A plus B minus, what is Y? Your Y represents or is represented by N of A intersection B. So A intersection B. If I do this, I will subtract 1Y here. And therefore I'll get my answer as A union B. That is how you get this formula. So the formula is basically a representation of a logic. Formula is not important. What is important is, do you understand the pieces which are being added together or subtracted together? That is what is the important part. Clear? So don't worry too much about the formula, but focus on what is the addition of the parts and subtraction of the parts that is happening. Okay? Then we are talking about things where there are three parameters, three circles. Once again, the logic remains the same. This is a circle which is representing P, or this is a circle representative of Q, this is a circle representative of R. Now, if you look at this part, the shaded region, what does it represent? The shaded region right now represents, that is A, B and C, they represent exactly one parameter. Right? They represent areas which signify belonging to single parameter. Similarly, if you look at D, E and F, they represent areas which correspond to exactly two parameters. Because you can see D belongs to both P and Q, E belongs to both C and P, F belongs to both Q and C, right? And finally, if you look at G, this represents the portion which belongs to three parameters. So exactly 3. So if I want to say A union B union C, which is the entire circle, is nothing but exactly one parameter, exactly two parameters, and exactly three parameters added together. Exactly one parameter, exactly two parameters, exactly three parameters, all added together, which is nothing but A plus B plus C plus D plus E plus F plus G. Right? Now, based on this, outside is H. Now, in the questions, they will not mention whether something is outside or not sometimes. The rule of the thumb is very simple. Unless they mention that everybody belongs to the circles or everybody belongs to one of the categories, you will always take that there are some people who are outside the circles and we don't know that number. If the question says a survey is conducted for students whether they like Pepsi or thumbs up, and everybody chooses one of the two, then it means H equal to 0. But if I just mentioned that a survey was conducted, 50 people like thumbs up, 60 people like Pepsi, you cannot take in such a case H to be 0 because nothing is mentioned about people who don't like both. It could be possible. So unless specified, you will always take somebody is outside the circle. Right? So please keep this in mind. Many students make a mistake here. This is one of the very simple points. Unless specifically mentioned, somebody is always outside. Okay? Now, you will again, based on the same logic that I showed earlier, you will get a formula which is, I hope it is there, yes. A union B union C. So A union B union C is nothing but A plus B plus C minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. This is a big formula, right? But don't worry too much about it. Again, the point is when you are adding this, this and this. So what is A plus B plus C? Or rather P plus Q plus R. When you're adding these three circles, look at this. A has this, let's say this is A, this is B, and this is C. I've used a different nomenclature, so don't get confused. So A, B and C, the capital A is a set. It has what all? A, D, G and E. Correct? B has D, B, G, F and C has E, G, F, C. Now when you add all of them, your A is getting added only once, that is perfect. Your B is getting added only once, that is perfect. And your C is getting added only once, perfect. But if you notice, your D is getting twice. Your G is getting twice. Your F is getting twice. Your G in fact is getting thrice. Your E is getting twice. E is getting twice. So D, E and F, they are getting added twice. But if you are looking at the entirety of the circle, everything should be added only once. That is why you are subtracting A intersection B. If you subtract A intersection B, that is this part, that will subtract D and G. D plus G, it will get subtracted. Similarly, you will subtract F plus G and then you will subtract E plus F. But now if you notice, 3 times the G is getting subtracted. G, G, G. E and F, E and G, sorry. 3 times G is getting subtracted. So you have to add back this G once again. So that is the logic. I'm not getting too much in depth about it. But the formula is not, again, it's not the starting point. The formula is a culmination of the logic of addition of pieces. Right? But moving on from this particular thing, next is permutation and combination. What are the important parts in P and C? Let's go ahead and take a look at it. Okay. The first formula is NCR. What is NCR as a formula? NCR is n factorial by n minus r factorial into r factorial. Right? This formula everybody knows. The result of this formula are these results. NC0 is always 1. What does it mean? It means choosing 0 objects out of n objects. There is only one way of doing, don't choose anybody. So if I say I have to, I have 10 people, I have to form or I have to pass 0 people from it. How many ways can I do it? Only one way, fail everybody. Correct? That is the meaning. The next one is NC1 is n. What does it mean? NC1 is n. The representation, the logical meaning is if there are 10 people, I have to pass only one person. How many ways can I do it? So choosing one person out of 10 people can be done only in 10 ways. Right? Because either first person or second person or third person and so on and so forth. And then we have the fourth one, which is NCN. Gives you the answer as 1. What does it mean? It means if there are 10 people, how many ways can I pass all of them? Passing all of them is done in only one way, which is basically make everybody pass, 0 fails. That is your one way. And then you have a final result. You have NCR is equal to NC n minus R. This is a very, very important result for you to keep in mind. It means when you have a group of, let's say, 10 people as an example, selecting 4 people is same as selecting 6 people. The logical meaning is very interesting. Think of it. If I say there are 10 people, I want to choose 4 of them for a work. How many ways can I choose them? The answer is 10C4. You all know this. If I ask you a question, listen, I have 10 people. I want to this time select 6 of them. How many ways can you do that? The answer is 10C6. But you'll notice that both of them are same. Why are these two values same? Logically, what is the meaning? Mathematically, you can understand what is happening. But logically, what is the meaning? The meaning is, when I select 4, automatically this other 6 are also forming into a group. The group called not selected. Similarly, when I select 6, I am already forming a group of 4. So, as long as you're grouping, the moment you pick one part, the other part is already formed whether you like it or not. So, selecting of 4 also means selecting of 6. So the answers will not be different for both the cases. It will be the same answer. That is the reason why NCR is equal to NC n minus R. Okay. And to help you in your calculations faster, make sure that you remember your factorials till 8. At least I would say remember till 7. So what is your 1 factorial? In fact, 0 factorial. What is 0 factorial? Anyone? Quickly. 0 factorial is how much? Guys, are you able to hear me? No answers? Right, 0 factorial is 1. 1 factorial is also 1. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24, 5 factorial is 120, and 6 factorial is 720, and 7 factorial. Till here you remember that is sufficient ideally. If you have more time, you can go for 7 factorial and 8 factorial too. Just multiply this by 7 and you multiply this by 8. The reason why I am asking you to do that is I don't remember it. Okay, so I survived for 15 years by remembering up to 6 factorial, that is enough. Yes, if you want to be a bit more faster, saving 5-10 seconds extra, you can remember up to 8 also. That is enough, more than that is not required. Okay, moving on. So this is one of the important concepts in combinations. The concept here is talking about total number of ways of selecting from n different things. Now I'll give you an example of what this means. What is the meaning of selection of, selection, number of ways of selection from n different things? An example is, let us say you have a party and you have 10 friends. So the question is, how many ways can you invite 10 friends to a party? Now, what is the meaning of inviting 10 friends? First question you need to ask is, how many will I invite out of this 10? Are all of them being invited or not? Is only 9 of them being invited? 6 of them being invited? What is that you are going to invite? That is the first question. Second question is, which of these 6 will be invited? Once you decide on how many people, then which of these 6 will be invited? So when you're looking at this basic idea, you will start with different cases. The case number 1 is 0 people invited. How many ways can you choose 0 people out of n people? It can be done in NC0 ways. Second case, 1 person is invited. Only 1 person. How can you invite 1 person out of the n people that you have? It is NC1. Third case, 2 people invited. Which 2 people? You have to choose any 2 people. That can be done in NC2 ways. And so on. Up to your case, final case, case number n, n minus 1 actually. You will be talking about, case number n. This will be n plus 1. Yeah, case number n plus 1. You will be talking about n people being invited. and this will be NCN. So the invitation can happen in this way or the second way or the third way and so on and so forth. So when you're using the word or, this gets converted into addition. Always or in PNC means addition. So the final answer will be NC0, NC1, NC2 and so on up to NCN. Now this comes in your expansion of binomial theorem also. X plus y whole power n in binomial theorem is NC0 x power n plus NC1 x power n minus 1 into y plus NC2 x power n minus 2 into y square up to NCN y power n. Now if you put x equal to y equal to 1, your left hand side becomes 2 power n. Right hand side you will get exactly what you want. What do you want? NC0 plus NC1 plus NC2 up to NCN. So this is what you will get. So the simplified version is 2 power n. Okay, there is one other logic with which you can get 2 power n without using binomial theorem. Let's also understand that. How do I get 2 power n without using a binomial theorem? So the logic is somewhat like this. Let's say you have friend number 1, friend number 2 and so on up to friend number n minus 1 and friend number n. So you will first go to a friend's house and you have two options. You either invite the friend or don't invite the friend. So the first friend, the job of inviting or not inviting can be done in two ways for the first friend. Similarly, the second friend also can be chosen or not chosen in two ways. So when you think about every friend you will have two ways to deal with the friend. Either invite for the party or don't invite for the party. But consider all the friends, first friend and second friend and third friend and so on and so forth. In this logic, you will think about every friend. You will think of the first friend, then you will think of the second friend and the third friend and the fourth friend and so on and so forth. So the word which is being used here is and in PNC, when you use the word and, this gets converted into product. So you are multiplying 2 n number of times. So that is 2 power n. This is the second way of interpreting your PNC and getting your answer as 2 power n. Clear? So if I ask you, how many ways can you invite 20 friends such that at least one friend is invited to the party? At least one friend is invited to party. Then the answer is 2 power 20 but minus 1. Why minus 1? Because this is the case where nobody is invited. The question I just repeated was, how many ways can you invite 20 friends to a party such that at least one is definitely invited? Which means this case you don't want in your answer. So if you don't want this, subtract this 1 because this is 1. So that one case you don't want, subtract it. So the answer will become 2 power 20 minus 1. So you have to be very careful whether they are saying at least one or they are just saying how many ways can I invite people for their party. Clear? That's the concept here. Let's move on and look at this. The total number of ways of selecting from n identical things. Now this is different. When I gave you the first part, here I took the example of people. What is the meaning of people? Inherently, every person is different from the other. Even if they are identical twins for that matter, one person will be a different person from the other person. Even if they look alike, doesn't matter. It is one person is A, the other person is B. So inviting A, not inviting B is different from inviting B and not inviting A. But that is for people. But when you're dealing with things, it doesn't work like that. When you see 3 dolls or 3 books, book number 1, book number 2 and book number 3. If I say how many ways can you pick one book? How many ways can you pick one book? Then you will not say NC1 here. You can't use NC1 here. Because the most important part about this permutation and combination that you need to understand, in this entire formulae, these n things are distinct. The n things are distinct. But when you're dealing with similar things, non-distinct things, identical things, right? You can't use the formula NC1. So now you have to look at, if there are 3 identical books, I can choose one book in only one way. It doesn't matter which book I pick. One book I'll pick, job is done. It doesn't matter which book because individually they don't have any identity. They're all the same. Similarly, so you can look at picking one book or picking 2 books or picking 3 books. Picking one book can be done in one way. Picking 2 books can be done again in one way. Picking 3 books can again be done in one way. So how many number of books there are, that many ones you will get. So the final answer will become n plus 1 because you can pick 0 books also. So if I am saying how many ways can you pick books out of 3 identical books. So 0 books, 1 book, 2 book or 3 book. So basically you can say 0 books can be picked up in one way, 1 book can be picked up in one way, 2 books also can be picked up in one way, 3 books also can be picked up in one way. It doesn't matter which 2 books I'm picking, it doesn't matter which book I'm picking. Because picking the first book is same as second book, which is same as picking up the third book. So when you're dealing with similar items, the individual identities are lost. They are all the same. So these two are important for you to keep in mind, distinct and identical cases. Clear? Moving on. Now this is again a very important concept of counting the number of paths. A question which has come in a lot of exams. So the question comes to you like this. There will be a grid given to you like this, and they say a person wants to go from A to B. A person wants to go from A to B. How many ways can the person go from A to B? What is the logic for this? The logic is, how many ways can the person go from A to B such that the path taken is the shortest? That is how they will mention. The path taken is the shortest. What is the meaning of shortest path? You can either go like this, or like this, or like this, or like this. All paths are same as long as they are only forward moving and upward moving. If you go like this, then come back, then go, then the distance will increase, correct? So coming back or coming reverse is not allowed. That is the meaning. So shortest path means only going forward or only going upwards. Now the answer, the logic for this kind of a question is, look, if I want to go from A to B, I have to go 2 times forward, I have to go 2 times upwards. It doesn't matter where I take them. Definitely 2 rights I have to go, 2 ups I have to go. So basically I have to take 4 steps. 4 steps. Out of which 2 of them are forward, 2 of them are upward. So now the question is, out of these 4, which 2 of them will be forward, which 2 of them will be upwards? So just choose 2 out of these 4. That is 4C2. The moment you choose 2, let us say I choose these 2, I will call these as up and up, which means automatically the remaining will become forward. So what route is this? Remember, first is up, second is forward, third is up, fourth is forward. This is my route. For every different combination of up and right, I'll get a different route. Let's take one more example. If I say it is forward, up, up, forward, what route is this? So forward, up, forward. This is the route. So for every different combination of this, I will be getting a route. So the question boils down to how many ways can I form this 2Fs and 2Us. So that can be done in 4C2 ways. 4C2 is how much? 4C2 is 6 ways. 4 factorial by 4 minus 2 into 2 factorial. This is 4 into 3 by 2. 6 ways. Not 8, 6 ways. Okay? Mandeep, I hope it is clear to you now what is the meaning of 1 plus 2 plus 3 in the previous slide. Moving on. Okay, so I explained the logic to you. Now, next is the permutation. So we have seen combinations till now. We will now see the permutation. What is the meaning of a permutation? In a permutation, the order matters. What does this mean? Remember, when I gave you the example of choosing 2 people, if I have 3 people, A, B and C, in combination, when I said how many ways can I select 2 people, you can say A and B can be selected, B and C can be selected, or A and C can be selected, correct? So you will say 3C2, which is nothing but 3, and this is the 3 cases, or these are the 3 cases. But when you're dealing with permutation, here it matters to me who's been selected first. So if I say how many 3-digit numbers can be formed, or how many 2-digit numbers can be formed using 1, 2, 3 digits. 1, 2, 3 digits, how many 2-digit numbers can be formed? This is given by 3p2, which is 3 factorial. In fact, the formula for NPR is n factorial by n minus r factorial. This is your formula. So this becomes 3 factorial by 3 minus 2, which is 1 factorial, which is 6 numbers. Why are there 6 numbers? Because 1, 2 is 12, whereas 2, 1 is 21. In the combination, your A, B or B, comma A are both the same. It doesn't matter to us. But when you're writing the numbers, 1, 2 is different from 2, 1. Similarly, 2, 3 is different from 3, 2. And 1, 3 is different from 3, 1. That is the reason why you get 6. So you will get more permutations than combinations when the number of things are same. Right? Is it clear? Right? Whenever you're using the word or, I already explained this, it is an addition. Whenever you're using the and, it is multiplication. That's basically what we already discussed. Let's move on. So this is the formula for permutation. I already mentioned this. Again, remember n identical. N distinct. So all these formulae cannot be used if the things are similar. You can't use the NPR formula or you can't use the NCR formula if the n number of things are not distinct. You can use the formulae only if they are distinct. Keep in mind. Okay. Now, how will this matter? How will this change if I have to arrange n things out of which p things are identical and q things are identical? So what does this mean? Let's look at the concept here. Now I told you n things should be distinct, only then you can use the formula directly. Otherwise, how will I do? So let's take this. My name is Srinivas, Srinivas. Okay. Now, if I ask you, actually mine is a bigger name. Let me take a smaller name, Robin Hood. So let me take Hood, right? And compare this with bird. 4-lettered word here, 4-lettered word here. If I ask you, how many ways can you form a 4-lettered word using the letters BIRD? The answer is you will get 4P4, because out of the 4 things you have to arrange all 4, so it is 4P4, which is nothing but 4 factorial, correct? But here, if I ask you the same question, how many ways can you form 4-lettered words using letters of Hood? You cannot say the same answer. It will not be 4 factorial. It will not be 4 factorial. Why? Because in bird, let us say BIRD is different from BRID. These are interchanged. You will get 2 different words. But if you look at Hood, HOOD, if you interchange these 2, you will not get a different answer. You will again get Hood only. So if you use the same formula, 4 factorial, you will get more. You will count more, but they are not supposed to count. This Hood is same as this Hood, right? You can't make the difference. So this answer should be lesser. How will you get that lesser value? That is given by the formula n factorial by p factorial, q factorial, and so on. Now what is this? N is the number of letters given to you. Out of the letters, p of them are identical of one type, q of them are identical of the other type, r of them are identical of the third type, and so on and so forth. So let me give you a bigger example. Let me take my name itself, Srinivas. So you have 1, 2, 3, 4, 5, 6, 7, 8. Good, I don't remember that I had 8 letters. So 8 factorial, if I am using all 8 letters to form a word. So 8 factorial by, how many S's are repeated? S's are 2. So 2 factorial for the S's. How many I's? 2 I's. So 2 factorial for the I's. Is there any other letter being repeated? No. There is only one V, there is only one A, and there is only one R. So no repetitions, leave it as it is. Whatever is getting repeated, depending upon how many times it is repeated, you will write that factorial. So the number of 8-lettered words that can be formed by my name is 8 factorial by 2 factorial by 2 factorial. Let's take a bigger example. This is a very famous, all textbooks use this. The city Mississippi. Sorry, the river Mississippi. Mississippi. Okay. So here, this is a 11-lettered word. 11-lettered word. Now, how many S's are there? 4 S's. How many I's are there? 4 I's. How many P's are there? 2 P's. This is your answer. Clear? So this is how you use this formula over here. And this is not just P and Q. It goes on how many other repetitions are there. Okay? Right, let's move on. Next is circular arrangement. So till now we are dealing with linear arrangement, forming of a 3-lettered word or a 2-digit number, they're linear. But when you're dealing with a circular arrangement, things will be different. I'll explain why. See, if I write A, B, C, 3 people sitting in a straight line, how many ways can you make them sit? Look at the possibilities. You'll have ABC, you'll have ACB, then you'll have BCA, you'll have BAC, then you'll have CAB, and you'll have CBA. 6 ways. But when you're sitting in a circle, think about it like this. There is A, there is B, there is C. So ABC is there. But if you start looking from here, you also have BCA, that's also there. Then if you start looking from here, you will also have CAB, that is also there. So in this one arrangement, 3 of them are already counted. So you can't say this answer is again 3 factorial. This will be wrong. Because 3 factorial means it will give you 6 answers. You don't have 6 answers because in this one arrangement you already got 3. So there should be something different here. So the logic here is, for circular arrangement, what you do is there are 3 chairs. All 3 chairs are same, right? That's the meaning of a circular arrangement. There are no chair differentiation. All chairs are same. Make one person sit here. Doesn't matter who is sitting. Any one person, A, B or C. Once this person is sitting, now you have 2 chairs. You have a reference point. You have a reference point. So the problem with a circle and a straight line is, in a straight line, whether anybody is sitting or not, this is called as first from left. This is called as first from right. The reference is left and right. Everybody knows what is left and right. But when you come to a circle, the reference point is gone. Because when you're talking about a circle, if I ask you what is the first chair, there is no point. Anything can be called first. So what you will do is first make one person sit. The moment one person sits, okay, you have a starting point now. Now once the reference point is set, you can treat this as a straight line. So this is cut out. Remaining are 2 people and 2 chairs. How many ways can 2 people sit in 2 chairs? It is 2 factorial. So if you expand it for a bigger number of terms, if there are n people sitting in a circle, then make 1 people sit in a chair, cut it out. Reference is now ready. So remaining people are n-1 people and n-1 chairs. So n things in n-1 p n-1, n-1 chairs, n-1 people, how many ways to arrange? That can be done in n-1 p n-1, which is nothing but n-1 factorial. And that is your answer. Clear? Okay, so this is the way in which circular arrangements will work. Now, in circular arrangement, this is about people. Now, when you're talking about circular arrangements, there could be another way of looking at it, which is necklace. Now, in a necklace, if you have A, B, and C, think about it as a pearl necklace. So pearls don't have a front and a back, correct? If you think about a pearl necklace, there is no correct side. You can wear it anyway, right? Because front and back doesn't exist for a necklace like a pearl. Which means when you arrange A, B and C, I will also get A, C and B just by reversing it. Without rearranging, I take the same necklace without any rearrangement, I'll just flip it. That is flipping it. If I flip it, I'll get another ABC. So while sitting people, I can't say I will reverse them, because the only way in which this arrangement, if it is people, the only way in which I'll get this person, this arrangement is when C gets up, comes here, B gets up and goes here. So you are rearranging. But if it is a pearl necklace, A, B, C are pearls, I will just flip the necklace, I'll get ACB. So my answer when I'm dealing with pearls or necklace, where the clockwise, counterclockwise or front and back differentiation does not exist. In such a case, my answer will be whatever is the earlier case divided by 2. So it is the people case divided by 2, because left and right do not exist. You will not count them separately, which means you will just do half of what you want. Okay, so what you wanted here is n-1 factorial, in case that is for people. When it is coming for a necklace, it will become n-1 factorial by 2. Clear? So this is the concept of P and C circular arrangements. And then moving on to dearrangement. So this is the formula for dearrangement. This is very rarely asked, but you can remember this. What is the meaning of dearrangements? So if there are n people, or rather, let me use the classic example, n letters and n addressed envelopes. Okay, n letters and n addressed envelopes. Now I want to post these letters. Every letter should be put into the correct envelope, obviously, right? So I'm sending it to 5 of my friends. Dear A, Dear B, Dear C. Obviously, A should go to the A's address, B should go to the B's address. Now, the question is, if I am randomly putting everything, how many ways can I put these letters into the envelopes such that no letter goes to the correct envelope? All will go wrongly. All will go wrongly. This concept is called as dearrangements. It is given by this formula. The dearrangement for n is given as factorial n, not n factorial. Factorial n is a symbol. This symbol basically says dearrangement of n things such that all n things are going wrong is given by n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. So alternately minus and plus till n factorial. Till n factorial. This is a dearrangement concept. Remember till here. This much is enough. Okay? Dearrangement concept up to 6 things going wrongly, all 6 going wrongly, is given by the value 265. Till there, if you remember, that is good enough. Right? Next. Grouping now. What is the meaning of grouping? So if you have A, B plus C objects and we need to divide them in 3 groups of A, B, C so that the number of ways in which this can be done. So look at this. What do I mean by this? So let us say that you have 20 objects, all distinct. Okay. You want to divide them into groups of 5, 6 and 9. So one group should be 5, one group should be 6, one group should be 9. How many ways or how do you do that? It can be done in first form the group 20C5. You formed 5 group. Now how many are remaining? If 5 are already gone, 15 are remaining. From that 15, select 6 more. And that leaves you 9. From the 9, select 9. This is the way in which you remember picking A, B, C type of number of objects from n number of distinct values. N number of distinct values. Don't worry about the formula which comes. Remember this concept. You pick 5 first, then from the remaining pick the next, and the third one will form a complete NCN or RCR. Clear? Subhash Singh, why are you worried about package? Are you telling me that based on the package you will decide whether to perform well or not? Subhash, I don't think that should affect your preparation. But trust me, IIFT will have some of the best packages even for freshers. I can guarantee that the freshers will get an average of something around 19 to 20 lakhs, probably more than that also. So don't worry too much about what is the IIFT package. Focus right now on only preparation. Okay. Now here, the groups have no order. I'm just forming the groups. I'm not giving any name for the group. But now imagine there are 3 classrooms. Classroom A, classroom B and classroom C. They're named classrooms. Now the question is, I have to form these 3 groups and send them to a classroom also. So forming can be done in this way. But after forming, there are 3 groups going into 3 classrooms. How many ways can I send 3 people into 3 classrooms or 3 groups into 3 classrooms? That is 3 factorial. Arranging of 3 things into 3 groups or 3 classrooms. That is 3 factorial. That is where this extra factorial will come when the group order or the group naming is also considered. Clear? Right? Let's move on. Now the next is a distribution rule. What is the distribution rule? So the number of ways of allocating or distributing n identical things into r distinct groups. What I mean by this is, let us say there are 3 books, identical books. Okay, I want to form 2 groups, group A and group B. I want to form 2 groups, group A and group B. Right? In fact, yeah. Let me change this. Yeah. So I want to form this into two groups, group of 2 and group of 1. How many ways can I do that? Now, if the groups are not numbered, if the groups don't have a name, then you put any two books here, one book will come here, game over. But if the groups are numbered, there is a group called A, there is a group called B, then 2, 1 here is different from 1, 2 here. So it matters when you're dealing with identical items forming into groups. The first thing you need to ask is, are my groups numbered or not numbered? If the groups have a meaning, if the groups have a name, then this will be considered separately. But if the groups don't have a name, I'll just say this is one group, the other group, there is no A, B naming. Then whichever gets 2 and 1 doesn't matter. Ultimately 2, 1 is what matters. Correct? So that is what we are talking about. So this can be better explained in this way. If you're talking about this case where so there's no direct formula here. So no naming. There's no formula. When there's no name, there's no formula. Typically, they ask you, if they say, how many ways can I form a group of 3 and a group of 5 out of 8 objects? They will not give you a long number of objects. They'll not give you 20 objects, 30 objects like that. They'll give you small number of objects. Because typically this is done without formula. But if I ask you, there are 20 identical chocolates, right? 20 identical chocolates. I have to distribute these chocolates into 3 children, A, B and C. How many ways can I do that? All 20 should go to A, B and C, right? That is a question. So how many ways can I distribute 20 chocolates to these 3 children? When the naming comes, then you're basically saying that A plus B plus C is equal to 20. So this comes to be sum of non-negative integers. This comes under the concept of sum of non-negative integers. So these are ABCs. Chocolates can go 0 to a person also. So non-negative, 0 is included in this. So if there are R items or R groups here and there are N items, N identical items, this is very important, identical. N identical items, then the formula is given by N plus R minus 1 C R minus 1. This is the formula for finding the number of non-negative integral solutions. However, if I change this, if I change the question and say A plus B plus C is equal to 20, where A, B, C belong to natural numbers, which means 0 is not included now. Minimum 1 should be there for everyone. Then what is your answer? Then the formula becomes N minus 1 C R minus 1. Then the formula becomes N minus 1 C R minus 1. Okay. So this is what you will be getting as the second formula. The next is addition probability wise. We are moving on to probability because the highlights of PNC are covered now. We are moving on to probability. The probability also, the values or the addition of probability are based on the sets. So A union B is basically P of A plus P of B. So if I say probability of A is half, probability of B is 1/3, and these two are independent. Independent means A is separate outcome, B is separate outcome, there's no relation. Then the probability of either A or B happens is given by this formula, which is the same as set theory wala formula. Okay, and P of A intersection B is given by P of A into P of B. A intersection B in independent terms is nothing but A into B. So this answer of P of A union B will become 1/2 plus 1/3 minus 1/6. So this is how much? 5/6 minus 1/6, which is 2/3. Okay, so this will become your answer. So probability, don't think it differently. It is basically the usage of set theory itself. That is one way of explaining things. Another way of dealing with probability, which is not directly with respect to set, is the idea of favorable things by total outcomes. So a probability is asked when an event is about to happen. So when the event is about to happen, any event whose outcome is not known, you are supposed to find the probability. If you know what is the outcome, what is the probability? It is 100% guaranteed. So when you're dealing with something happening and you want to find the probability of a particular case, then the numerator should talk about that particular case can be done in how many ways using P and C. And the denominator should have when you're doing this experiment or when you're doing this event, totally how many cases are there. For example, if I say probability of getting 6 in a dice. So 6, how many 6s are there? Only one 6 is there. And when you're throwing a die, total how many outcomes are possible? Totally 6 outcomes are possible. So the answer is 1 by 6. This is the favorable case. Favorable means what you want to count. This is the total number of cases as an outcome. So 1 by 6 is your answer. So probability can either be dealt in this way or it can be dealt in the set theory fashion depending upon how the question comes to you. Both of them are related, but I don't want to get into the depths of the relation right now. But frankly, right now you can understand that if the question talks about A union B, things like that, you can use set theory concept. If it is using normal probability, you can understand the concept over here. Okay. Now, what about mutually exclusive events? What is the meaning of mutually exclusive events? Mutually exclusive events means two events are such that they cannot happen simultaneously. They cannot happen simultaneously. Okay. In fact, mutually exclusive. So let me give you an example. Yeah, let us say that I am tossing a coin. Okay, let us say that I am tossing a coin. So when you are tossing a coin, if I am getting a head, okay, then obviously you can't get a tail, right? Because you can't get both head and tail at the same time. So in such a case, if you're saying A union B, frankly the answer will be 0 because both cannot happen at the same time. But what can happen? What can happen? So A intersection B. A intersection B will be 0. But if you're talking about A union B, what does it mean? It means either head or tail. It is nothing but by the set theory, P of A union B, N of A union B is A plus B minus A intersection B, correct? But this is 0. So what are you left with? You're left with A plus B itself. It's not a new formula. It's just that this is becoming 0. So when you're dealing with mutually exclusive events means both cannot happen at the same time or three things cannot happen at the same time. Because if one is happening, automatically the others are not happening. Let us say a match of let's say badminton or a table tennis. You can't have a draw. Cricket you can still have a draw. But in a badminton it doesn't end in a draw. A table tennis the rules are such that it will not end in a draw. So then if I ask you, two people, let's say Lee Chong-wei and Lin Dan are playing. I mean, I'm of an older era. They are both retired now. And if I ask you, what is the probability of both of them winning? It can't happen. Obviously, Lee Chong-wei is winning. It means Lin Dan is losing. The other way around. If Lin Dan is winning, it means Lee Chong-wei is losing. So this is called as a mutually exclusive events. Both of them together in the same event. They can't come out as winners, right? So in such a case, either this guy or that guy winning, the answer is 1. Why? Because when a match is happening, either he will win or he will win. So if I ask you either him winning or the other person winning, the answer will always be 1. Because there is no other third case possible at all. Clear? So that's how mutually exclusive things work. What are mutually exhaustive events? Mutually exhaustive. Exhaustive means all possible scenarios taken together. Mutually exhaustive events means all possible scenarios are taken into account, and if you add all their probabilities, the answer should be 1. So if there are two events and I call them, this is mutually exhaustive set. It means when the experiment is happening, all the possible outcomes are only 2. So which means either this will happen or that will happen. So the total probability should add up to 1. So the summation of the probabilities of a mutually exhaustive set will always add up to 1. Right? And independent events, this you already know. Independent events, I already told you. Why is this like this? Because this is P of A intersection B. A intersection B is nothing but P of A into P of B when it becomes, or when the events become independent. Right? So this is what we already saw. Right. Then there is something called as condition probability, which is quite rare. I'll just give you a glimpse of this. So condition probability basically says probability of something A happening given that B already happened. Given that B already happened. So what is the meaning of A happening given that B has happened? Let's take an example. Yes, so let us say there is a bag 1 and bag 2, right? Bag 1 and bag 2. So there are 2 red balls and 1 green ball, and this has 3 red balls, 2 green balls. Now I say I draw one ball randomly. I draw one ball randomly and I found it to be from any one bag. I pick a bag randomly and I draw a ball randomly. And I found the ball to be red in color. So the question now is, if this is observed to happen, so I closed my eyes, picked one bag randomly, and I then saw the color of the ball, and that is red. Given that it is red color, what is the probability that it is coming from bag number 1? So the event will be written as, calculate the probability that the ball is coming from bag number 1, given is this line, given that the ball color is red. So find the probability that the ball is coming from the bag number 1 given that the ball is red. So the events are supposed to be read as P of A given B. And this formula is given by P of A intersection B divided by P of B. This is a simple formula. This is called as conditional probability. Typically, this is how the structure of the question is formed. Find the probability of something happening provided something else has already happened. So what has already happened, they will mention to you. They will ask you, if this has happened, what is the probability that this is happening? Such a thing is called as conditional probability. Okay, and that's the formula as I already told you. Clear? So these are the basic concepts of your probability and P&C. Let's go ahead and take a question based on that, or not one question, few questions based on that. Are you all ready? Can I have a quick round of responses from all of you? You have your pens and papers? You're all ready, guys? Yes? Alright, so this is the first question coming your way. Think about this, it's a very simple question. Give me an answer in about 40-45 seconds. First question coming your way. Okay, that's your time of 45 seconds. Let's take a look at what is happening. There are 6 numbers that are positive, 5 numbers that are negative. You're randomly picking 3 numbers and you're finding the probability that these product of the 3 numbers is positive. Now when you're multiplying 3 numbers, the answer can be positive in how many ways? All 3 can be positive, or 2 of them are negative and 1 more is positive. So basically 3 positives or 2 negative and 1 positive. These are the 2 cases. Is there a third case? No. So find the number of ways in which you can pick 3 positive numbers. So positive numbers will come from here only. That is 6C3. Order doesn't matter, you're just choosing them. Because whichever way you multiply, the answer will be the same, so it doesn't matter. So 6C3 or means addition. 2 negatives. 2 negatives is 5C2. And means multiplication. You want 1 positive. 1 positive is 6C1. So 6C3 is 6 into 5 into 4 by 3 into 2, which is 20, plus 5C2 is 10 and 6C1 is 6, which is 80. The correct answer is option D, value 80. Very simple question, a warm up to start. Next question. Look at this. Again, not a very difficult question. Give me a quick answer. There's a formula for this. If you remember, that's good. Otherwise, I'll give you the formula. What is the answer, anyone? Right, so the formula for this is n minus 1 factorial into 1111 n times into sum of the digits. Sum of digits given. Now, sum of digits given in the formula, what is the meaning? It is 2 plus 3 plus 4 plus 5 plus 6. Okay? 111 n times, what is n? N is the number of digits that are there in the number that is formed. See guys, here 5 digit numbers and 5 digits are given and you're supposed to find a 5 digit number. But I can have a question where there are 7 digits and only 5 digit number is being asked. So the n here and the n here talks about what is the length of that number that is being formed, not the number of digits given to you. So here it will be 1, 2, 3, 4, 5 and then 4 factorial. This is the answer. Is this clear? Right? So this will give you the answer as option D. 533280. Remember this formula. It is n minus 1 into 1111 up to n times into sum of all the digits given. So if I ask you how many 3-digit numbers can be formed, then the answer this will still be the same because this is the summation of all digits given. But this will become 2 factorial because n minus 1, 3 digits. So 3 minus 1 is 2 into 111. And then you have the sum of 2, 3, 4, 5, 6. Clear? That's how it will change. Right? That's the formula. Please keep in mind. Now, but guys, before we go ahead, please give me a like on this particular session if you like and if you enjoy more sessions like this, you want more sessions like this, please give me a like on this session and subscribe onto our channel so that we can conduct more and more sessions, because we take your likes and your subscription as a kind of feedback. So whichever sessions you are giving us more likes, more feedbacks, or rather more subscriptions, we will take that as a positive sign and we'll put more sessions like that. You give less feedback to maths, we will cut down on maths, probably we'll put more of English. You want more English, you please like there. You want more of maths, please give us a like here. You give likes for both, we'll keep continuing with both. So it's all in your hands, right? Let's go forward. So that's your option D. Next question. Look at this. This is an interesting one. Try this. I'll give you 1 minute for this. Okay, that's 1 minute. So let's take a look at this. The probability of getting a particular number is directly proportional to the square of that number, which means probability of getting 1 is proportional to 1 square. Probability of getting 2 is proportional to 2 square. Probability of getting 3 is proportional to 3 square, and so on and so forth. So let us say the proportionality constant is k. So probability of getting 1 is k into 1 square, which is k. Probability of getting 2 will be 4k. Probability of getting 3 will be 9k. Probability of getting 4 will be 16k. Probability of getting 5 will be 25k. Probability of getting 6 will be 36k. Now, if you add all the probabilities, because this is a set of exhaustive events, you can't get anything else, 1 to 6 only are possible. So if you add the probabilities of all of them, it should add up to 1. So if you add all of them, what do you get? You get 36, 25, 16, 9, 4, 1, which is adding up to 91. So 91k is equal to 1. So your k should be 1 by 91. Your k should be 1 by 91. Now what is the probability of getting a prime number? What are the prime numbers? 2, 3 and 5. So probability of 2 or 3 or 5. So probability of 2 is 4k, or means addition, 3 is 9k and 5 is 25k. How much is this? 25, 35, 38, 38k. Where is your total probability? Which is 38 by 91, option B. So Sai Pradeep, very good. That is the correct answer. Okay, let's move on. It's a good question. Try this out. It's a set theory question. Actually, it's a simple one because it's the first question in set theory. Give me an answer. This will not take you more than 1 minute. It should not take you more than 1 minute. In fact, if you get the logic, you'll get the answer in few seconds. Alright guys, so that's about a minute. In this question, what you need is this 50 and this 10, that's all. This entire thing is irrelevant till here. Till here, you don't need this at all. Why? Let us understand. You have 3 types of channels, TV, YT and app. All together is 50, correct? All together is 50. 10 of them have all 3, so 10 of them are in here. What is the question? How many have at most 2 of the 3? At most means maximum 2. Maximum 2, which means total minus all 3. Correct? Because what you can have? You can have 0, you can have 1, you can have 2, you can have 3. Those are the all cases. So 0, 1, 2, 3. The sum of all of them should add up to 50. Now these 3 is what you need to add. You don't want all 3. So just subtract that one thing. So 50 minus 40, 50 minus 10, the answer is 40 over. This entire structure is given just to confuse you and waste your time. You just need to pick this 50 and this 10, job is done. Clear? Let's move on. Okay, look at this question, give me the answer. This is actually a good question. I'll give you 2 minutes to solve this. So this will be the last question, I believe. Take 2 minutes, give me the answer to this. Alright, so that's about time. Okay, what is mentioned here? A box 1, so let me write down, box 1 contains 4 green and 7 blue balls. box 2 contains 5 green and 5 blue balls. Now one ball is drawn at random from box 1 and dropped into box 2, and then one ball from box 2 is picked and dropped into box 1. Now a ball is picked from box number 1. Find the probability that the last ball drawn is box number 1 is green. Now let's look at what are the cases. So case number 1 is going ball is green, coming ball is also green. Case number 2, going is green, coming back is black. Case number 3, going is black, coming back is green. And case number 4, going is black, coming also is black. Is there any other case possible? No. These are the only 4 cases possible. You need to find the probability that out of the 4 cases, in all the 4 cases, you can always get a green ball at the end. So you can get a green ball either in the first case or in the second case or in the third case or in the fourth case, which means find the probability of getting a green ball in each of the cases and then add them. So let's take the first case. First, a green ball should go. What is the probability that a green ball goes? It is 4 out of 11. So 4 by 11. Right? Because probability of picking one green ball from the first bag, it is 4 by 11. And now you put the green ball there. So now what do you have? You have 6 green balls and 5 black balls. Now you want a green ball to come back. So now it is 6 by 11, because when you're picking one from bag 2, it is 6 out of the one green ball out of 6, that is 6 divided by total is 11. Now you are again back to same structure. You want one green ball to be picked up. Finally you're picking one ball that has to be green. What is the probability? That is 4 by 11. Or second case, one green ball is going there. That can be done in 4 by 11 probability. But this time a black ball is coming back. Now remember, when a green ball went there, the greens became 6, but blacks are still at 5. So black ball picking now is 5 by 11. Now when the black ball came, what is the structure here? The structure here is 3 green and 8 black. 3 green and 8 black in the first bag. Now you want to pick a green ball. It is 3 out of 11. Or the third case. What is the third case? Let me write the third case here. A black ball is going. So black ball is going will be 7 by 11. And a green ball is coming back. When a green ball is coming, remember, when a black is getting added here, the greens will still remain the same. Only the blacks will increase. So it is 5 by 11. And then finally, your black went and green came back. So total greens will become 5 out of 11. And then the fourth case, I will write it over here. Black went and black came. So now if you got the logic, you will get 7 by 11 into 6 by 11 into now black came back. That is 4 by 11. So sum of all of these. 11 into 11 into 11 is 133. Now the addition of these 3 or 4 values, this and this, will give you 499. So the correct answer is 499 out of 1331. Is that clear? Right? Let's take, actually we have some more time. Let me take one more question. Okay, look at this guys. This is again a very interesting question. Give me the answer to this. This is not lengthy at all. Give me an answer in about 1 minute. If you get the answer in 1 minute, that is good. Otherwise, you will never get the answer. Think about it. Thanks, Clash Royale. Yeah, comments like that will help me understand whether you are getting it or not. Quickly guys, anybody got? Another 30 seconds I'll give you. Alright, so let's see what is happening here. So you have 6 faces, correct? This is your 6 faces. Now, when nothing is painted, all 6 are same. It's like a circular table. Doesn't matter where you start. So start with first side. Now let us say this side and this side are same painted. Let's take it like that. So it can be painted with any of the 5 colors. So whatever it is, 5 colors here, the same color will be repeated. Which means the front side is 5 ways of painting, the back side only 1 way, because whatever is coming here will come there. Now, the upper face will have 4 ways and the lower face will have 3 ways. So what did we have right now? 5 into 1 into 4 into 3. But remember, when you're dealing with a cube, so imagine like this, color 1, color 2 and color 3 in the top and color 4 in the bottom. So this is front, back, top and bottom. If I twist it, I'll get the same thing. So when I take this 4 into 3, basically what happens is, it is counting color 3, color 4, top and bottom, different from color 4, color 3, bottom and top. But you and I know, because when the cube, it is identical from all the sides. So whether color 3 is at the top or color 3 is at the bottom, the counting should not happen twice, because it will look the same. So I should divide this by 2. I should divide it by 2, because mathematically 4 into 3 is 12, but visually when I look at it, top and bottom different colors. If I just invert it, I'll get bottom and top, just like your necklace wala case. So by 2 is what I need. Similarly, now this side can be filled up with 2 colors and this side will be filled up with 1 color. So 2 into 1. But again I'll get a by 2 here. Why will I get a by 2 here? Once again, left and right is same as right and left when you're talking about visualization. So it should not count it multiple times. So the answer will be 5 3s are 15, 15 2s are 30. The answer should be option C, 30. Right, so I hope you guys got the logic of why 30. The division by 2 is the important factor. If you did not divide by 2, you will get the answer as 120, which is what Clash Royale has been mentioning. But 120 is not correct, because we know when the cube is identical, left and right, top and bottom are all the same. So the by 2 factor should come. Right? Let me see if we have a good, this again, okay, this is a good question. I want to try this, guys. I keep saying last question, but yeah, this is a good question. Try this. It depends on how you make your Venn diagram in this. Okay, look at this question. It's a simple one. If you do it rightly, it becomes lengthy if you take the wrong starting point. I'll give you 1 minute for this again. Any answers, anyone? This is the last question, guys, so let's focus on this properly and get an answer out of it. So here's the starting point. So what I'll do here is I will draw 2 parameters, but this will represent people not in Zumba and not in yoga. So I will not start with people in yoga and in Zumba. I will start with people not in yoga and not in Zumba. Which means, can somebody tell me what does this outside set represents? Outside is what? Anyone? Quickly. What does the outside area represent? Quick answers? Right. The outside area represents people in both. People who are in both. Not, see, neither is here. Neither is the intersection. Because if you are not in Zumba, not in yoga, it means it is not in both. That is the intersection part. Outside means you are there in both. Outside means you are there in both. So that's the nice way of looking at this question. So it's reverse of what you are usually doing. So now total people are 200 members. Total are 200 members. Okay. Number of people who do not attend Zumba or yoga is 8 more than the number of members who attend both. So number of people who do not attend Zumba or yoga. So let's say this is X. It is 8 more. So let us say this is X. So this will be X plus 8. Okay. Is 8 more than the number of people who attend both. So number of people attending both outside is X. I will take neither is X plus 8. Number of members who do not attend Zumba is 10. 10 more than the number of people who do not attend yoga. So let us say yoga is Y. Not attending yoga is Y. So Zumba should be Y plus 10 according to the question. Now the question is, find the number of members who do not attend Zumba. So this is what they're asking, not in Z. Y plus 10 value they're asking. That's okay. Now we know that this circle, which is Y plus 10, plus this part, okay, whatever that part is, plus outside X, should add up to 200. Do you agree? In any Venn diagram, when you add everything, it should add up to 200. Now what is this part which I am shading here? It is Y minus X plus 8. So Y minus X minus 8. This should add up to 200. So X will get cancelled. You will get 2Y equal to 198. So you will get Y equal to 99. If Y is 99, then Y plus 10, this will become 109. And that is your answer. This question will become complicated if you start with Venn diagram as people in Zumba and people in yoga. I'll not say it is complicated, but it becomes a little bit more lengthy. But this becomes very straightforward if you start with the parameters as not in Zumba and not in yoga. That is the best way to solve this kind of a question. Right? So with that, I'll come to the end of my session. I have a few more questions, but I will, these are all easy questions, guys. So yeah, I think this is the last, yeah, this is one question I want to take up. I'll give you 30 seconds. It's a direct formula. That's the reason why I want to give you this question. Please do this. I want one question of this to be solved by you. It's a direct formula, but the formula is important. Try to do this. Any answers? So the formula here is very straightforward, guys. When you have R variables, but remember R distinct. Distinct means you cannot have A and A square in it. A and A square are not called distinct because one is derived from the other. So when you have R distinct, so A, B, C or X, Y, Z, all of them are different. Please note this formula is not applicable in this case. A square or X square, X cube, it is not applicable. When you have R distinct items raised to the power of N, the number of terms is given by N plus R minus 1, C R minus 1. This is the formula. This, if I give you X plus X square plus 1 plus X square raised to the power of 5, how many terms are there? Or if I give you this will still get an answer. But if I give you 1 plus X cube plus X power 5 raised to the power of 10, you can't apply any formula here. You can't apply any formula here. It's very difficult to get the answer. Such questions usually will not come. If it comes, leave it. This is a very lengthy process. But if this comes continuous from 1 to X power N, continuous, nothing is missing. Here if you notice, X square is missing, X power 4 is missing. So it's difficult. But if nothing is missing, then straight away the number of terms will be 5 into 2 plus 1. 5 into 2 is 10 plus 1. Right? That is a straightforward answer. Here there is a straightforward formula. Remember this. So the answer here is 5 plus 3, 8 minus 1, C, 5 minus 1, which is 7, C4, which is 35. And the answer option is D. This is a direct formula application. In fact, this comes from the number of non-negative integral solutions. The concept behind is that. Okay, if you're interested in the concept, I'll give you a very quick idea. See, any term will have A into B into C into D into E. They could be powers 0 to 3. The powers can, for each term, can be 0 to 3. For example, if you see B cube, what does it mean? It means A0, C0, D0, E0. But B is cube, which means every term I can convert in terms of A, B, C, D, E product, but the powers will tell me whether the term exists or not. So I am looking at the sum of the powers will always add up to this n. You can't have a binomial expansion whose sum of the powers will be more or less than n. It should always be exactly equal to n. So you have 1, 2, 3, 4, 5. 5 things getting added, powers, adding up to 3. But some of them can be zeros. They should add up to 3. It is nothing but number of non-negative integral solutions. That's the logic, right? With that, I will end the session, my friends. I hope you guys enjoyed this. If any of you are there for CAT 2023, we are having these courses launched very, very soon. In fact, some of them are already launched. So we will reach out to you, or you can reach out to us on these channels that we are present. In fact, yeah, so I think there is a number given. No. So you can, in fact, if you're downloading our app, anyway, you will be downloading the app with our number, so we will be able to reach out to you. But these are the courses which are available for CAT 2023, as well as these are the upcoming sessions, guys. We have Monday, 7 days to IIFT. We have Tuesday, 6 months GK, because there is GK in your IIFT. We are going to do this. Understanding the logic behind logical reasoning. Then we are talking about GK once again, because GK is an important part. And then we have acing DI. All these sessions are coming to you in the next few days. The dates are already mentioned. Stay tuned with us, subscribe to our channel, and don't forget to click on the bell icon, because you need to get the notifications once the sessions are going live, or one day before. We are there on December 18th to do a comprehensive analysis. In fact, I myself will, with my colleague, Mr. Saral, will be taking the analysis for IIFT. So please be with us to understand how the paper is, what could be the potential cutoffs. We will do a very in-depth analysis. Right? So see you guys. I hope you enjoyed the session. Give me a like if you liked it. Follow us on all these channels. Thank you, and all the very best in your preparation.